Hello, AP Calculus students. I'm going to cycle through the various sections of the delta math that you have assigned for tomorrow. However, to list out the ones I'm going to go through in this video, it's going to be calculating higher derivatives, which you can see is already clicked on right here. Then also implicit differentiation, the second derivative, and then finally derivative rules graphically. Now, this middle section, implicit differentiation level 1, 2, and 3. Those I have already done a video on those. That was the last assignment. So I would direct you for this middle section to those videos if you need refreshing on those. Now, calculating higher derivatives, let's start with this one, has a pretty simple concept, right? So they give us a function f of x. I'll just write down f of x right here. F of x is equal to x to the negative fourth minus 1/5 x plus 1/2, right? Now, this is f, and notice there's two apostrophes, so that means I need to take the derivative 2 times. That's all it means. So to get to the 2 times, well, first I need to take the derivative 1 time. So let's find f prime of x, right? F prime of x would be power rule, so I'm going to bring the negative 4 down, negative 4x, and then after I bring negative 4 down, which I did, I'm going to subtract 1 from the exponent. So instead of x to the negative fourth, it's going to be x to the negative fifth. Cool. Now let's continue. Derivative of negative 1/5 x. Whenever it's just a number in x, then the derivative is just going to be that number. So it's just going to be negative 1/5. Right, 1/5. The x disappears. Finally, plus 1/2. Derivative of any number is 0. So I can imagine that as plus 0 or just make it disappear. Cool. So that is the first derivative, or f prime. Now I need to find the second derivative, or f double prime. So f double prime. So all I need to do is work from here and do the derivative another time. So negative 4x to the negative fifth. I'm going to take this negative 5, bring it down. So it's going to be negative 5 times negative 4 is 20 x, and then I subtract 1 from the exponent. So it's going to be negative 6. All right, that should be our answer. So let's put that in. 20x to the negative 6. Perfect. Cool. Well, that's how you do these problems. Let me see if there's any harder ones. Okay, just so we know, this is also the second derivative. This is labeled that means it's the second derivative. Okay, let's try this one because it looks a little bit tougher. All right, so they gave us y is equal to negative 1/8 x minus 2x cubed minus 1/3 x to the negative 3 minus 1/6 x to the negative 1. Cool. I need to find, this is the third derivative, right? d3y dx cubed. That is that Leibniz notation that we talked about in class. Okay, anyway, to get to the third derivative, we have to go through each of our derivatives. So let's first find the first one. The first derivative, I might go through this kind of quick. So go through it slowly. You can pause the video if you aren't understanding how we get my derivatives. But my first derivative of this function is going to be negative 1/8 minus 6x squared plus 3x to the negative fourth. Notice it is plus because I'm taking negative 3, this exponent. I'm multiplying it down by negative 1/3. Actually, that's just, 1x. So positive 1x. Because negative times negative is positive. Then I subtract 1 from negative 3, so it's negative 4. Cool, and then that one's going to be plus 1/6 x to the negative 2. Cool, that is my first derivative. So let's go on to my second. My second derivative is going to be written like this. That's just the notation. That just means second derivative. So it's the same thing as, right? Those mean the same exact thing. These are the same thing, right? Cool. So, here, let me just erase this, and I'm going to do my second derivative. Derivative of negative 1/8 is 0. derivative of negative 6x squared is negative 12x. Then minus 4x to the negative 5. Then minus 1/3 x to the negative 3. Okay, there's my second derivative. Now I'm almost there. I need to do the derivative one more time, though, to find my third derivative. Right? Cool. So, let's find my third derivative. Negative 12 plus 40, plus 20x to the negative 6 plus x to the negative 4th. That should be right. Okay, negative 12 plus 20x to the negative 6 plus x to the negative 4th. Yes, that looks right. Cool, there's our third derivative. All right, hopefully that makes sense. So that's how you do the calculating higher derivatives problems. Now I'm going to skip these. Remember, level 1, 2, and 3, we should know implicit differentiation by now, right? Actually, we can sort of go over the basic steps since I have to do this next section anyway. However, the level 1, 2, and 3, you should be doing on your own. All right, let's go through them. So, okay, this one's going to look sort of unfamiliar, so hopefully this video will be helpful, right? We need to find d2y over dx squared. So we need to find the second derivative, right? Basically, we need to find the second derivative. Now, with implicit differentiation, what do I know so far? So let's take step 1 of implicit differentiation. Notice I need to do implicit differentiation. Actually, I'll write this out. Need to do implicit differentiation because, why do we need to do it? Because all the x and y's are mixed up. X and y are mixed up in the equation. It's messy, basically. So that's why I need to do implicit differentiation. Cool, so let's do step 1 of implicit differentiation. Step 1, check your notes if you still don't remember this, but I'm hoping with our practice on the last Delta Math, you do remember this. We're going to take d over dx of both sides. All right, so let's do that. D over dx, first of this left side. The left side is just 0, so d over dx of 0 is equal to d over dx of y minus y squared minus 2x cubed. Cool. Step 2. Okay, we are going to, step 2, this is like the key step. So actually, I'm going to star it. Step 2. That's not, actually, I can't really star it. Okay, so what we're going to do is we are going to take the derivative of both sides regularly. Okay, take the derivative of both sides regularly, but hopefully you remember this. But if it is a y term, we multiply by dy over dx. That's it. So we take the derivative of both sides regularly, but if it is a y term, we do multiply by dy dx. Okay, cool. So let's do that. What is the derivative of 0 regularly? It is 0, right? And is that a y term? No, so I just leave it. Next one, derivative of y. What's the derivative of y? It would be 1. However, is that a y term? Yes, so I'm going to multiply by dy over dx. Cool. Then minus derivative of y squared is 2y. But it's a y term, so I multiply by dy dx. Finally, minus derivative of 2x cubed, that would be minus 6x squared. Is that a y term? No, so we're good. All right. Step 3 is solve for dy over dx, basically. So to do that, here, let's simplify this. This is just dy over dx. So dy over dx minus 2y dy over dx minus 6x squared is equal to 0. Well, I want to solve for dy dx, I want all of dy over dx terms by themselves on one side of the equation. So I'm going to move this negative 6x squared to the other side. So it's going to be positive 6x squared is equal to this whole thing now. Cool. Now I can factor out dy over dx. So 6x squared is equal to dy over dx times 1 minus 2y. Now, hopefully you kind of see this. This is just me taking dy over dx out from each term here. So when I take dy over dx out from this term, I'm left with just 1. When I take dy over dx out of this term, I'm left with the 2y. So that's what I did here. I factored out dy over dx. Notice if I distributed this back in, dy over dx times 1 is this. Dy over dx times negative 2y is this. All right, cool. So that means dy over dx is equal to 6x squared divided by 1 minus 2y. Okay, cool. Now, we are not quite done yet for a very specific reason, because they ask us for my second derivative. So actually here, let me pause here. So if I stopped here, this would be basically relevant to the other level 1, 2, and 3 of the implicit that we did before, right? However, I cannot stop here because I need to find the second derivative. So let's follow the steps again. Step 1 is d over dx, right? We just do the implicit differentiation steps another time, basically. Step 1 is I take d over dx of both sides. All right. Derivative of this, of dy over dx, is going to be my second derivative. It's going to be d2y. So it's going to be here. Let me just copy and paste this actually. Oh, never mind. I didn't write it yet. It's going to be d2y divided by dx squared. Oh, wait. Sorry. I'm going to write this as step 2. So step 2, take the derivative regularly, but if it is a y term, multiply by dy over dx. Cool. Okay, this is my step 2. So derivative of my derivative is my second derivative. Cool. Now derivative of this whole thing. What does it look like I need to do? I know this is going to be a decent amount of work, but again, important to go through the steps, and then you get faster and faster at it, although this problem's just going to take a long time no matter what. What does it look like I need to do to find the derivative of this? Ideally, if in your head you're saying quotient rule, you would be right. So we need to actually do a quotient rule. So let's do that quotient rule down here. U is equal to what? U is equal to 6x squared. V is equal to 1 minus 2y. U prime is equal to 12x. And V prime is equal to, well, derivative of 1 is 0. Derivative of negative 2y would be negative 2. However, remember, this is all implicit differentiation. It's not just negative 2, it's negative 2, and I need to multiply by dy over dx. That's the key. Right. Cool. Now let's plug this into my quotient rule. Hopefully you have this remembered. vu prime minus uv prime all over v squared. Right, so I'm just going to, remember, I'm finding the derivative of this. Let's use my quotient rule. I found everything I need here and plug it into this equation again. So I said vu prime. Well, v is 1 minus 2y times u prime, so that's 12x, minus uv prime, so minus 6x squared, times v prime, negative 2 dy over dx, all over v squared. V squared, so it's 1 minus 2y squared. Cool. Okay, so I found my second derivative, right? Because, I mean, I followed all my steps. I found my second derivative. Now, here, to find my second, to officially find my second derivative, I guess there is a final step, right? Step 3 would be solve or in this case, I'm solving for my second derivative, right? So I'm solving for my second derivative, and we kind of already did. Okay, let me just check that I input everything correctly really quick. All right, good. I just want to, slight mistakes here can be very annoying, so let's check our work. Cool. So that's my second derivative. Now, the one thing you might say is, okay, I have everything. It looks okay. I mean, obviously it looks messy, but I have my x, y, everything, except I have this weird dy over dx in here. That's kind of weird, right? It's like, how do I get rid of that? Because I don't even know what that is exactly. Well, if you remember, in the course of this problem, way back when, I solved for dy over dx. So it's this. Dy over dx is that. All right, so I'm going to take this dy over dx. I'm going to copy and paste it and plug it in for my dy over dx here. There we go. All right, so officially, this would be our second derivative. Now, they ask us to plug in to find the second derivative at this point, at -1, 2. So let's think about that means. That means x is equal to -1, y is equal to 2, right? This is the x coordinate, -1 is the x coordinate, 2 is the y coordinate. So I'm just going to plug -1 and 2 in for each of these. All right. So let's plug in 2 for y, -1. Actually, here's what I'll do. I'll plug in 2 for y for the whole thing first. Cool. Now let's plug in -1 for x. Make sure you use your parentheses. All right. Looks like that's our answer. So once I plug it in, I got 1.323. So what is this really saying? Just to be clear, this means y double prime is equal to 4 over 3. 4 over 3 is 1.333, sorry. 4 over 3 at the point -1, point -1, 2. Okay, so I found my answer though. It's 4 over 3. Cool. And if you ever need help, they have the answers here, or the step-by-step work. So hopefully that makes sense. All right. Yeah, you can kind of see how they went along with it. They found their dy over dx, 6x squared minus 2y, right here. You see that? Then quotient rule, etc., etc., etc. Plug it in, 4 over 3. All right. Hopefully that makes sense. Let's refresh this and do our last activity, which is derivative rules graphically. Now, I was hoping y'all could, I think if you know how to do these, you can figure out how to do it pretty well. So given the graphs of f of x and g of x, so this is the graph of f, down here is the graph of g, right? Below, and h of x is equal to f of x times g of x, determine the value of h prime of 0. So first, I need to find h prime. I need to find the derivative, right? Now, how do I find the derivative of h of x if it's f of x times g of x? Let's think about what rule am I going to have to use? It's f of x times g of x, so I have to use product rule. Product rule, right? Remember my product rule is u v prime, or actually the way I wrote it at the end of class was vu prime plus uv prime, right? Whatever way you remember it, it's fine. Just make sure it's the same thing. Okay. Now let's solve for everything. What is my, honestly, if you're good with product rule, you might be able to skip ahead, like shorten these steps a little bit, but let's see. My u is my first function, so u is f of x, right? What else? V is g of x. Cool. That means u is g prime. Sorry, f prime. Sorry, I'm not thinking. U prime is f prime of x, and v prime is g prime of x. Excellent. Cool. So I found my u, v, u prime, v prime. Now let's just plug it into my product rule. So it's vu prime. So it's going to be g of x. Oops. G of x, f prime of x, plus uv prime. So plus f of x, g prime of x. All right, so this is my official derivative right here. Now determine h prime of 0. So I'm going to plug in 0 for all of these. So 0, 0, 0, 0, and 0, because I'm plugging in 0 for x, right? Well, let's solve for that. So first, g of 0. What is g of 0? Well, that's pretty easy to find because they gave me my graph. I'm going to go to the graph of g. I go to 0, and I see it's -3. So g of 0 is really -3. Wait a sec. Okay, -3. Oh, whoops. I'm supposed to erase g of 0, replace it with -3. Next, I need to find f prime of 0. Now, let's think about what that means. I have given the graph of f, right? But it's my f prime 0 is not just going to be 1, because remember, this is f prime. It's not just f. This is the graph of f. I want to find f prime. Well, remember, what does f prime mean? Well, it means the derivative. The answer is that it means the derivative, aka the slope. Right, so really, f prime of 0, I'm not looking for, again, just the y value of 1. I'm looking for the slope here. So the slope at x equals 0 is, I'm just going to visually look at this, go over 1, down 3. So my slope is -3. So f prime of 0 here is -3. Hopefully you start to get the gist of what we're doing. Okay, next, f of 0. This is just asking me straight up. I go to graph of f. I go to 0. The y value is 1. Next, g prime of 0. So same idea here. I go to the graph of g. I go to 0, but I'm not looking at -3. I'm looking for the slope at 0. So I go to my function here, and I'm going to find the slope. My slope here is I'm going over 3, then down 3. So this is a slope of -1. -1. All right, I'm just going to put this in a calculator. Well, this simplifies to 8. Cool. Let's plug that in. 8 for my answer. All right, perfect. It all worked out. Okay, hopefully these problems were helpful. I think I did go a little bit long on some of them, but hopefully that's a good thing, not a bad thing, and you can skip around, pause, do whatever you need. All right, have a good one, y'all. Best of luck. Bye.